Namaskara.
Namaste.
See, my name is Murallee Krishna, working as General Manager Projects in Mangalore Refinery Center. I am a Mangalorean or Kannadiga from almost 29 years. I can't idea. I think many of them will
here.
Yes. Now, due to this water crisis, why we have gone for the desalination plant in MRPL? First I am coming to you. During 1920, we faced an acute crisis and our refinery has gone for a shutdown for more than 2 months due to the water shortage. So, due to that reason, management has taken a call that we have to go for a desalination project so that a refinery can sustain, because fresh water we are not able to get it. Whatever the fresh water from the Netravati, what we are getting it may be sustainable for the drinking purpose and we cannot use it for the industrial purpose. That is the root cause first starting point for the start of this desalination project in Mangalore for our MRPL purpose. Coming to this, see, wherever 97% of the water is a saline, salty water throughout the globe. So definitely, whatever the freshwater resources, only we have 3% or 3 to 4%, that's it. Remaining most of the water we have throughout the globe is around 97%. So what is the next alternative? Now people are going for the, up to now, as our eminent speakers has spoken many things, really I learned a lot today from them. See, earlier we are going with the nature, now due to the urbanization and many more things, there may be a small deviation from the nature. So, what are the freshwater resources what we have? It may not be sufficient for our sustenance. Reason? So that is the reason. Currently, throughout the globe, there are 16,000 desalination plants. Okay, really producing 70 million meter cube per day. 1 meter cube, already sir has said, it is around 1000 liters. So this much of saline water we are converting into the fresh water for the purpose of purpose. Next, first of all, the source is raw water. The raw water sources, one is the sea water and next one is the brackish water. Brackish water means the salinity of this brackish water is lesser than the sea water. So these are the sources for this one. Next, there are some technologies. We have different technologies available. The major thing is, one is that reverse osmosis. Second one is the MED, that is multi-effect distillation. In this one, multi-effect reverse osmosis, we are giving the higher pressure to the molecule, breaking it from passing to that one, that whatever that heavy molecule that will be broken out and that all the solids will be brought out, converting it into the fresh water. This is the process what being used in the reverse osmosis. Whereas for the other, it is a thermal distillation technologies where we are using steam and other things, so that it will be evaporated and from there we are taking as a fresh water from that one. All the salt deposits will come down and we are taking out. But that will be a bit costly and handling the steam and other things will be a bit difficult. Now, coming to the next one, how a desalination plant looks like. I am not hindering you, right? It is visible?
Yeah, visible.
Yeah, fine. So now, if you are coming here, first of all, we are taking, there is an intake. If I am going, it is obstructing me. Okay. This is the point where I am taking the water from that one. From there, again it is going here. This we are called the pre-treatment section. Okay, this intake way, then pre-treatment section. From this one, yeah, I can use this point. I can use this point. Which one? Center one. Which is the point? It is the pre-treatment section, and after all this pre-treatment, then we are going to the filtration method. From the filtration to the filtration process, this is what the reverse osmosis states. And from here, what are the result and other things? When I am coming to our MRPL process, I will explain in detail. And then we are taking out here after the reverse osmosis, we can have either we are going for the potable water or industrial water. Potable water is the sense it is a drinking water. There, if you are going for a potable water, there you need to add your carbon dioxide, calcium, chlorine and all to convert this water into the drinking water. Such plants we call it as a remineralization plants. In MRPL facilities, we are not having any remineralization plant. Directly from this one, we are taking as a industrial purpose. This we call it as a potable water. Clear? And anybody having some doubt, you can stop me, no problem. Okay, these are the various sections. Next, how in that 1, 2, 3, 4, 5, what I have shown. In this one I am coming in. How we are taking? There are two types. That is open intake, the first one. This is open intake, and then this is the surface intake. The second one, these are the surface intake. This is for the small quantity, will go by this surface intake type, whereas for the bigger, larger volume, we are going for the open intake type. What we are using this one is the open intake type. And next, the second one is the pre-treatment section. Whatever the dirt, heavy solids, all these particles, everything we need to segregate from that one. And from that one, we have two systems. First one is the media filtration, and second one is the membrane filtration. The second one is the membrane filtration. And next, going to that one, then in the membrane filtration, what we are doing is desalination, all the dissolved solids, we are removing it. And the other method, what we are doing is the thermal distillation, but we are using only going over the first one called membrane desalination. Next, here in this one, our speakers, I think Murallee sir has told, energy is required and other things. In this also, there are energy recovering devices are there, because for this reverse osmosis process, we need more energy in sense, it is up to some, you can take it as 70 bar pressure, we need that. So for that one, what we are using is, we are using an energy recovering devices. By using this, whatever see, first of all, the seawater is coming, the seawater is a low pressure one. We are using one high pressure pump here. Using this high pressure pump, we are putting here and taking out. And when we are going outside of this one, the low pressure water will go this side, and again this high pressure vessel stream will be there. Again we are using this energy recovering device, we are putting this one so that with less support, that means here I need 70 bar, here almost 67 bar I have recovered. That means only 3 bar pressure energy if I can give, I am going to get it in this one. Sir, in this reverse osmosis methodology, what we are adapting at MRPL, it is we are recovery rate is around 45% recovery. That means, suppose if 100 liters of desalination water we are taking, that means out of that 100 liters, 45 liters it can be converted into the fresh water. In this part, that's why what we call it as recovery. Okay, but overall recovery of the plant to the other losses, we can say that our desalination recovery is up to 38% to 39% is the recovery. That means around 100 liters of water, that seawater we are taking, and then we are putting around 39 liters of fresh water we can able to take. Right, sir? And next, and this is the, I told you, this is the section we are not installed, because our requirement is for the industrial purpose. So we are using If you see here, there are two things. If this desalination water, if you want it for the boiler purpose, we can use it a demineralization plant. We are calling it a DM plants. Suppose if you are using for the drinking purpose, you have to use it remineralization. There we are adding carbon dioxide, that lime, milk of lime, all those things, chlorine, to convert this one to the drinkable water, the drinking water. We call it as a potable water. But this particular installation we are not installed at MRPL. Reason is we are not using the desalination for the drinking waters. Okay? Because our limitation is to we want to use it only for the production of the industrial purpose processing. Now sir, what are the key factors required for the performance of the specific cost determining factors? One is the feed water characteristics. See sir, it is depending upon the area of sea where you have selected. If the sea water content is having so many algae and other problems, then your cost will go up. Reason is all the chemicals, dosing and other things will go up. So that is the reason. One is that feed water characteristics is more important. Next, the product water quality. What kind of product water quality you are expecting? Whether you want it in industrial water, whether you want a potable water, depending upon that, the product water quality this one. And then plant capacity. What are the plant capacity you are putting back? We are in MRPL refinery, we are using the desalination plant of the 40 MLD. That means 40 MLD is the capacity right now. 40 MLD means 40 million liters per day. And if you are converting into the general this one, 8.8 MGD, million gallons per day. This is the conversion, production what we are doing right now. Okay. And next one, this one is plant reliability. How often the plant we can able to produce. If the plant keep on you are setting up a desalination plant, but the plant is not performing properly, the reliability of the plant, reliability of the technology, all these things are also very much important. And next coming to that concentrate of disposal. See sir, I have told you, I am taking 100 liters of water. I am producing fresh water of around 40 liters per hour. Then remaining 60 liters, what I have to do? I have to put it in the outfall. But when I am putting to the outfall, I have to take care that all the environmental norms I should take care. The disposal should be in such a way that what are the salinity conditions for the, that means what are the biomechanism of all the water bodies, water animals that should survive. So I have to put back in a proper way that all this one should be sustained. Unless that I will not get the environmental clearance to run this plant. Okay, this has to be taken. So that's why that is also incurs you the cost. Okay, and next is the space where you are keeping it. Suppose our desalination plant just we have kept adjacent to the season, or else if you are keeping somewhere long, all this pipeline again reservoir water putting back, it is a tedious job and it will be very difficult to manage. So that's why choosing the location, that also matters for the successful running of any desalination project. This is one of the key factors people have to keep in mind. Okay, that incurs the cost. And next one, what is the operation and maintenance? How much operation and maintenance? Because how much operation? Because you have to maintain the chemicals, you have to, because always you are taking a desalination, salty water, clogging will be there, you have to disperse all those things, take it out, all the sorts of other things, then only it is possible for you to maintain the plant, reliability of the plant can be maintained. This is the next thing. Oh, I hope there is no clarity. Is it clear? My English is okay? My language is okay? Right, fine. Yes sir, coming to the cost factors, this is an important factor I think everybody is anticipating. See sir, if I am going with the RO plant, it's depending upon, suppose, see one is that how the life cycle of the desalination plant we have taken it. Okay, this is a capex for the equipment and mechanical things for the 25 years, capex for all these things have taken, capex for civil constructions, OPEX that is operating cost, and then depreciation, interest for investment, then price index in line with the annual inflations and other things. By that, if you take it, cost of producing 1000 liter, that liter cube means 1000 liters, is, if you take it all together, you can get it life cycle cost. It is coming roughly, it is not this one. So in future your energy and other things is coming down, that rate may come down. Okay, so it is coming up to 60 rupees. 60 rupees per meter cube for production of desalination water into a fresh water. Okay, hope this is clear. Next, how, where, pardon sir? How, where and all the components, how this distribution, how it is happening, this graph gives you that. That is maintenance 2 to 9%, chemicals, personal, energy, all these things will comes to the cost of the water, the price I have shown in my slides. This is other one, we are not using it, it's costlier than what here this one. A comparison I will give you. This is roughly, I have taken the rough calculations, sir. It's a rough, it is not like this one. If you are taking an electrical, this one, SWR, don't see this number because it is costly than this one. Okay, electricity cost I have taken 3 rupees per unit. Okay, if you are taking that one, maintenance cost, then other steam I am not using here, operating cost, all together it is coming nearly 58 rupees to 60 rupees. That is where the bar chart are. Now, coming to our desalination plant, this project was commissioned in December 2021, sir. And then the capitalized cost is around 677 crores. That is for 30 MLD. For the 30 MLD, this is my capitalized cost. That plant was constructed by consultant is Krishna Consulting Engineers. If somebody wants, they can consult them. And LSTK contractor who has done this is Messrs. Viatech Wabag. This was located in Chennai. Sir, you have told Chennai, they have Manali. That is, they are 100 MLD, 150 MLD desalination plant was made by them. In Peru, you have told no, 400 MLD desalination plant they are going to construct. This is Viatech Wabag is the contractor who is executing that job. Okay, and next other one, that's a 30 MLD is not sufficient to us. So our management will take a call. We have given me a task of within 7 months, I want to give the another 10 more MLD. That means 2.2 MGD to sustain. So for that, I spend around another 54 crores because before when I am constructing the 30 MLD plant, that was made an availability for the expansion up to 70 MLD. That is the reason within a short span, because all the civil structures are available with me, everything is available. Only the streams and other things I have to put it and bring up the plant. So it will be another 54 crores. Now around 730 crores. We have a desalination plant of around 40 MLD desalination plant is in MRPL. From the last March onwards, this 40 MLD is running. So due to this, we can able to sustain our refinery production. For drinking purpose, we are getting 3 MGD water from the fresh water for the drinking water facilities. We can able to make it. Another remaining thing, we have our own effluent treatment plant, recycle water also. We are using it to sustain the refinery process requirements. This one, sir. And next, see, what are the attributes of MRPL desalination plant? Capacity 40 MLD, further it can be expandable up to 70 MLD. Desalination plant to supply process water, the TDS less than 100. For drinking water TDS, if you ask me, it will be around 100 to 150. Okay. And then state-of-the-art technology, pre-treatment system, intake, outflow system, what we have. And next, with a pipeline, then after the product water to the refinery from Tanir Bavi, we are pushing around 10 kilometers pipeline we have, sir. 10 kilometers pipeline we have. So we are pumping that water to the refinery. And next, product distribution inside the refinery also, we have a distribution network of around 10 kilometers network we have inside the refinery. And then what we have done here is, we have given operation and maintenance to the same WABAC team to maintain this plant. Okay, so for this one, I am spending 120 crores for 10 years for 30 MLD, another around 17 crores. That means altogether around 130, 140 crores I am spending for the running of this refinery, this desal plant. For the next another 8 more years, this can be maintained by Baba. For that I am paying for that. Okay. Next, how it looks, ultrafiltration. These are the various systems we have in our desalination. One is the intake system, electrochlorination, lamellar clarifier, handling ultrafiltration, seawater, then brackish water, outfall, product water, and it looks like this. Ultrafiltration looks like this, and this is a lamellar clarifier. Some of the pictures for the clarity you can understand how it looks. And this is what our seawater reverse osmosis. Okay, the membranes, pressure vessels, it looks like this. We know that one. The pressure tube, what I have told you, the pressure exchanger, that one. And these are the pumps and other things, the reverse osmosis. This is the backwater, brackish water osmosis. We have brackish water also. And then we are having, see, that is the equipment. Now, how we are producing desalination water into fresh water. I have time, right, gentlemen? I have time?
Yes, sir.
Yeah, thank you. See, now, coming to the first part. See, this is the intake way. From our facility to the sea, we lay into the sea 10 kilometers pipeline, sir. There is a HTP pipeline. It's a size of around 44-inch pipeline. And depth of that one, 7.7 to 8 meters depth we have kept inside. The water will be come out with the gravity. That we call it as a caisson, which holds there to keep that one. And it has a full mesh and other things to avoid all the jellyfish and all. And here we are not applying any much pressure, so that even the fish comes out, it can sails back and go out. There is no harm for the marine bodies. Okay. There after that, the seawater comes to the seawater bay. This is the seawater bay. After that, we have the 2 streams. One is crash guard stream and traveling water streams. This one, all dirt particles, all these things, all these particles will be removed. And from there, we are putting this water into a intake chamber. We have the pumps to pump that one. To the next one is this is for the lamellar clarifier. Here the clarifier, all the silt and other things will be deposited at the bottom, and from there we are getting. Sir, here the interesting factor you have to understand is the seawater TDS. Total dissolved solids in the seawater, it is around 40,000 in the Arabian Sea. It is around 40 to 45,000 mg per L. Okay, this is the seawater salinity. That what we call it as a turbidity. That is around that is this one TDS, and this one turbidity of this one is around 40. That is also nearly 500 NTU. Okay, and then after this one, this is all the after the pre-treatment. Again, one more pre-treatment section. This is the ultrafiltration. Here, the total water will be ultra-filtered, and then all the fine this one will come, except the dissolved, total dissolved TDS. Okay, that will maintain like that. And then from there, next this particular thing is coming to my SWRO. The beauty of this SWRO, this is a system. We have total 4 trains. Each train capacity of around 10 mld. So total 4 trains we are having it. So in this each train, we are having 114 pressure vessels, and each vessel consists of around 7 membranes. That means almost in one train I am putting around 798 membranes. Okay, like that. From one side I showed you, one side that the pressure at this one side I am giving with the high pressure, the other side it is heating, the molecule will be broken, all the dissolved salts will fallen down. The fresh water is coming out from the fresh water is coming out from the outlet of this one, and this one, the TDS is how much you are expecting? 350. Where is 40,000? The outlet of this one is 350. Okay. From this one, again, we are putting to one more osmosis process, that is called brackish water, BWRO, brackish water reverse osmosis. In this brackish water reverse osmosis, what we are doing is, Here also, again it passes through the membranes and systems. The TDS here will be 20. The TDS, whatever it is coming out, 350 to 20. Okay, finally we will blend some water, and whatever the TDS we are sending to the refinery is from here we are using the product water pumps, and to the refinery we have a tanks were there. So in that one we are putting this water into these tanks, and then from there we are distributing to the refinery. And whatever the result it has come, that particular result we have taken out like this, and from here by using a diffuser, what I have told you, because it will be more salinity than what we have taken. So to diffuse the salinity to match with the seawater, to maintain the water bodies, what are the water animals and other things, fish and other things, they should not, they have to sustain. So to maintain that one, I am using the diffusers and then putting back to this one. Okay. So friends, it is a process, we can do it, it is not the thing like that. The main thing is, sir has told, we have to go with the nature, that is the important thing. Suppose if it is not sufficient, yes, definitely I am using this plant almost from 2021. Now almost you can say last 23-22 my refinery has sustained, sir. Without this one 100%, 110% I have refined this one. My refinery capacity is 15 million metric tons. We have refined of 17 million metric tons. Now this year also almost from the March we had the crisis as everybody is facing. But my refinery is running at the full throughput. So absolutely no problem with the help of this desalination plant. But even though the freshwater cost will be less, you may be around, somebody may ask what will be the freshwater cost for you. It may be around 6-7 rupees per meter cube. But whereas the desalination water I am spending around, for this purpose because I am not using the remineralization, my cost may be around 45 rupees per meter cube. This is where I am using this water because my downtime is more costlier than the whatever the investment I have put it here. So that is the reason we have gone for this. Hope I am not boring you. Right? Okay. Thank you so much for your patience listening. Hope my time I maintained.
Yes.
Thank you, sir. Thank you so much.